Hello everyone, I'm Professor Xiaonan Gao. Welcome to the General Chemistry class. This session will continue with the atmospheric gases and hydrogen chapter. After the introduction of nitrogen in the previous session, this session we will learn the characteristics and properties of oxygen. Oxygen is essential to a study of chemistry. It forms compounds with all the elements except the noble gases of low atomic numbers. We constantly find ourselves considering properties of oxygen and its compounds as we encounter new chemical principles. Oxygen gases can be used in many fields. Take some examples we are familiar with. When manufacturing and fabrication of irons, steel, and other metals, the fire needs oxygen to tune the temperature for cutting and welding. Oxygen is also a very strong oxidizing agent. Well, by its name, you can also tell that. Therefore, oxygen is widely applied oxidation reaction processes. Other applications like water treatment, rocket fuel, medical use, petroleum refining are all commonly known. Okay, then how can we get oxygen? I bet everyone's quite familiar with this picture, the classic way of producing oxygen in the lab. The decomposition of the potassium permanganate yields oxygen as a gas product, and it can be collected in the bottle filled with water. Other reactions like decomposition of potassium chloride, potassium superoxide with carbon dioxide are also common methods for producing oxygen in labs. Oxygen and hydrogen gases can be obtained simultaneously through electrolysis of water. Electrolysis is the decomposition of a substance through the passage of electric current. This method is cost-effective for producing only small quantities of this gas unless the electric power is unusually cheap. The passage of the electric current through a liquid involves the migration of ions. To make the water an electrical conductor, an electrolyte such as the sulfuric acid must be added. The electrolysis occurs in aqueous sulfuric acid solution. Hydrogen ions in the acidic solution are attracted to the negative electrode, called the cathode. Here are how they gain the electrons to form the hydrogen atoms, and hydrogen atoms join to form molecules of hydrogen. Reduction occurs at the cathode, like this way. And sulfuric ions are attracted to the positive electrode, called the anode, but they undergo no change. Instead, a reaction occurs in which water molecules decompose to replace the hydrogen ion lost at the cathode and release the oxygen gases. And this is the oxidation occurs at the anode. Therefore, the overall reaction is this. 2 water molecules decompose to form 2 hydrogen molecules and 1 oxygen molecules. Although we usually think the formula of oxygen as oxygen gases, there are actually 2 different oxygen molecules. Familiar oxygen is dioxygen. 2 oxygen atoms forms a molecule. The other one is trioxygen, called ozone. The term used to describe the existence of 2 or more forms of an element that differs in their bonding and molecule structure is called allotropes. The reaction producing ozone directly from oxygen gas is highly endothermic and occurs only rarely in lower atmosphere. This reaction does occur in high-energy environments such as electronic storms. The pungent odor you may have smelled around heavy, dirty electronic equipment or xerographic office copiers was probably ozone. The shift method of producing ozone in the lab is to pass electric discharge through oxygen gases. Therefore, electrons will offer the energy to the oxygen molecules to separate apart first and then combine to another oxygen molecule to yield the ozone molecules. In the stratosphere, at altitude between 25 to 35 kilometers, the concentration of ozone is about 20 times higher than the ground level. This belt of the stratosphere is called the ozone layer. Stratospheric ozone plays a vital role in protecting life on Earth. First, ozone absorbs certain ultraviolet radiations that at Earth's surface causes skin cancers, eye damage in humans, and also harmful to other biological organisms as well. Second, in absorbing UV radiation, ozone molecules dissociate, involving heat, and thus helps to maintain a heat balance in the atmosphere. The chemical reactions that produces ozone in the upper atmosphere are as follows. Oxygen molecules absorb UV radiation and dissociates. Atomic and molecule oxygen then react to form ozone. The third body, M, usually nitrogen, carries off extra energy away. Otherwise, the ozone formed would be too energetic and simply decompose. This reaction illustrates the two functions of ozone, absorbing UV radiation and releasing heat into the atmosphere. And the last equation is an ozone destroying reaction that occurs naturally. But however, in the past decades, certain gases produced by human activities are contributing to the ozone depletion and threatening the integrity of the ozone layers, especially gaseous chlorofluorocarbons. These molecules have a very long lifetime in the atmosphere and eventually rise to the stratosphere in low concentration. In the stratosphere, they can absorb the UV radiation and dissociate. Chlorine atoms from these reactions set up the ozone-destroying circle and plays as a catalyst. The ozone depletion makes humans on Earth in danger. Therefore, the production and uses of the chlorofluorocarbon have been significantly reduced all over the world. Alright everyone, in this session we learned the characteristics of oxygen and ozone. I hope you have enjoyed the class and I'll see you next time.